This video is going to take you through practice 3 and 4 of your parametric equations day 1 notes. So to start, question 3 says, write the rectangular equation 5x plus 4y equals 20 in parametric form given the parameter t equals 4 minus x. So what we want to do is we want to go ahead and come up with two equations, right? When we're looking at parametric form, what that means is we're looking for some expression, x of t and y of t, okay? So to start, we'll notice that we're given the fact that the parameter is equal to t equals 4 minus x. Now, it's kind of quick to come up with x of t to get x by itself, right? You can see that you could subtract over the 4 and you get t minus 4 equals negative x, and then we can divide out negative 1, right, to all of these terms, and that tells us that x, which I'm going to actually write as x of t just to remind myself that x is a function of t, x of t equals negative t plus 4. So we're actually halfway done, right? What we've just done is we found our x of t equation, okay? So now the focus is going to shift to finding your y of t equation. How can you define y in terms of just the variable t? So if you look at your equation given in this statement, the problem statement, it says 5x plus 4y equals 20. So right now, even if we just worked to isolate y, we would have y equals something that is an expression or an expression defined by x. And we actually want an expression defined by t. So instead of letting x kind of hang out on your equation, you're going to utilize this equation that we just found. We found that x is the same thing as negative t plus 4. So over in our original equation, 5x plus 4y equals 20, we're going to rewrite that as 5, and now not times x, but times negative t plus 4, plus 4y equals 20. So now what we notice is we are at least in the correct variables, right? We have our t, our input value t, and our output value y. And so now all that remains to do is kind of clean this up and get it into the form y equals some expression in terms of t. So in order to do that, I'm going to go ahead and distribute our 5. We get negative 5t minus 20, plus 20 plus 4y equals 20. I notice that on both sides of the equation I have 20, so those will cancel. You can either see that right away, or I can go through the process of subtracting 20 from either side. Regardless of that approach, we're going to end up with negative 5t plus 4y equals 0. And remember what our goal is. We're trying to get a statement, some function, y in terms of t. So we want to keep working to get y alone. So the next step would be to add over our 5t, and that will show us that 4y is equal to 5t. And finally, we can go ahead and divide out the 4, and we find that our y of t function, or we can just say y, equals 5/4 t. And our final answer would be both of these equations, this y of t equation, this y equals statement, or this x of t, this x equals statement. So our final answer is both the fact that y of t equals 5/4 t and the fact that x of t is equal to negative t plus 4. Okay, so we're going to go ahead and in the same video jump down to all 4 parts of problem 4. Problem 4 is telling us to eliminate the parameter t and write the corresponding rectangular equations. Okay, so we want to take we want to be able to express these two parametric equations as one expression relating x and y. And there's a couple different ways we can do this. We can start by solving x equals 3t minus 3 for t, or we can solve y equals 2t plus 1 for t. It doesn't matter, and I'd actually encourage you to do both and compare your answers. But I'm going to go ahead and work on solving x equals 3t minus 3 for t. So I'm going to isolate the variable t. So I can add 3 to both sides, and that will give me x plus 3 equals 3t. I'm then going to divide all of these terms, right, both sides of the equations, both of those terms on the left-hand side by 3, which will give me 1/3 x plus 1 equals t. So I'm going to rely heavily on this fact, on the fact that t is equal to 1/3 x plus 1, and I'm going to utilize that in our other equation, in our y equals 2t plus 1, right? I'm going to take the fact that t is equal to 1/3 x plus 1, and I'm going to actually plug that in to my y equals equation for that variable t. So in doing that, I get y equals 2 times 1/3 x plus 1 and then plus 1. And at this point I can do some simplifying, right? I can distribute my 2 to the 1/3 and find that y is equal to 2/3 x plus 2 times 1, which is 2, and then we have that trailing 1 at the end. So what I've done is I've written y in terms of x. Okay, I've written a rectangular equation given two parameters for x and y. So we started with x and y defined in terms of t, and now we're able to express a rectangular equation, right? We eliminated that variable, or eliminated the parameter t. And again, I'd encourage you to do this the other way. Take y equals 2t plus 1 and isolate t, and then go ahead and plug that into your x equals equation and see how your answers compare. Okay, so let's go ahead and look at b. b tells us that x is equal to t squared and y is equal to the natural log of t. Okay, so right off the bat, I think personally that it's easier to deal with x equals t squared and go ahead and isolate t from there. So in order to isolate t, we're going to have to square root both sides. And we need to remember that when we square root and we're solving, we have to consider positive and negative answers. Okay, so we have to consider that t is equal to plus or minus square root of x. However, it's important to realize that we're told that t must be greater than 0. So here what we can do is actually just pick the positive square root. So from our first equation, we're able to say that t is equal to the square root of x. And now we can go ahead and, just like we did before, we can take this expression, this t equals square root of x, and instead of writing t in our y equals equation, we can go ahead and write square root of x. So this gives us the rectangular equation y equals natural log of square root of x. And I know that I'm done because I've eliminated my parameter, right? I no longer have that parameter of t hanging out. I have an expression for y based upon x. All right, so looking at example C, I'm going to actually here choose to isolate t in the second equation. Okay, I can quickly get t alone by dividing out that 5. I can see that t is equal to 1/5 y. And now I'm in a position to take that statement t equals 1/5 y and utilize it in my x equation, right? I can go ahead and plug 1/5 y in for t in that equation. So it might be a little bit more clear if I just circle the fact that t is the same thing as 1/5 y, and I'm going to go ahead and replace that into my x equals equation. So I'll have x equals 4 times, instead of t, 1/5 y, and then plus 2. And we can go ahead and clean this up a little bit. We can say that x is then equal to 4/5 y plus 2. And if you reference the guided notes answer key, you'll see that you can actually take this a step further and multiply the entire equation by 5 and get that 5x is equal to 4y plus 2. And if you so choose, like this would be an okay answer, but if you would like, you can go ahead and continue working to get this into a more familiar rectangular equation form by isolating your y value. So we could go ahead and say that this is the same thing as 4y equals, oops, and it looks like I forgot to multiply that guy, right? It looks like in my distribution back in that, back in this step, it looks like I forgot to apply that 5 times 2, so that should actually be, here that results in 4y plus 10. But back to what I was saying, we can go ahead and manipulate that 5x equals 4y plus 10 into a more familiar rectangular form where we have y by itself. So in subtracting, what I could do is I could subtract the 10 over to both sides and have 4y isolated and by itself. So I'd have 4y equals 5x minus 10. And lastly, I could divide everything by 4. I could divide out that 4 and get that 5x or 5/4 x minus 10/4 or 5/2 is equal to y. Okay, so again, this is an okay answer, and this is also an okay answer. This 5x equals 4y plus 10. It's kind of preference there, and also it depends on, you might be seeing these skills in a multiple choice situation, and so if you were able to get to the statement that 5x equals 4y plus 10, you'd want to be able to make that manipulation potentially if y equals 4/5 or 5/4 x minus 5/2 was an answered choice and the 5x equals 4y plus 10 was not. Okay, so our last example for this video is question 4, part D. And here I think that you're kind of safe to isolate either one, or isolate t in either one of these equations, although with that coefficient to 3 in the exponent of your y equation, that one might be a little bit more difficult. So I'm going to go ahead and choose to isolate t from my x equals equation, and this is a good reminder of how to solve exponential equations. Remember that in order to solve an exponential equation, we need to go ahead and take the natural log of both sides. So if I take the natural log of both sides, I get natural log of x equals natural log of e to the negative t, and hopefully we remember that natural log and e, they're inverses, right? They undo each other. So that gives us the statement natural log of x is equal to negative t, and quick division of that negative tells us that t is equal to negative natural log of x. Okay, so I have my parameter t expressed in terms of one of my rectangular variables, and so now I can go ahead and plug that into my other equation. So we'll see that y is equal to e to the 3 times negative natural log of x. And here we have an opportunity to practice some logarithmic properties as well as properties of exponents. So I'm going to go ahead and write this exponent is actually y, -3 natural log of x. I'm going to remind myself of this power rule of logs, right? Something that is a coefficient out front can also be expressed as a power to my natural log. So I can actually rewrite this further and say that y is equal to e natural log of x to the -3rd power. And why I do that is so I can leverage that inverse of e and natural log and actually cancel those here and find that y is equal just to x to the -3rd. Or if I want to be even more rigorous in my answer, I can say y is equal to 1 over x to the +3rd power. Okay, right? Because negative exponents aren't something that make a ton of sense, so we can go ahead and utilize the properties of negative exponents to go ahead and rewrite that final answer. But either way, you have accomplished that goal of eliminating your parameter. You started with two expressions of x and y in terms of t, and you were able to use them together to come up with one equation in terms of just y and x.